Alright, what's up guys? In this video we're going to pick up some more calculus here. I'm going to be talking about alternating series. So we have to determine if this series converges. So we're given this series from n is equal to 0 to infinity. Got negative 1 raised to the n plus 3 all over n cubed plus 4n plus 1. So the first thing that you want to make sure you do is to first determine if this is an alternating series or not. And it clearly is. So that's the first thing that you need to be checking. You certainly don't want to try to apply a test to a series in which it's not specified for. For example, you don't want to apply, or you can't apply the alternating series test for a series that's telescoping or vice versa. So you have to make sure that you're in fact dealing with an alternating series. And this is in fact an alternating series. Now, alternating series can take two forms. Okay, so the two forms for the alternating series. So we'll have a sub n is equal to negative 1 raised to the n multiplied by b sub n, where b sub n is greater than or equal to 0. Another way is a sub n is equal to negative 1 raised to the n plus 1 multiplied by b sub n, where again b sub n is greater than or equal to 0. So again, this is in fact an alternating series. So the alternating series test basically, first of all, remember that an alternating series test will only tell us whether or not a series converges or not. The alternating series test is not a divergence test. It does not tell us anything about divergence whatsoever. Okay, and remember the conditions for the alternating series test, which I'll write them down, and both conditions need to be met in order for the series to converge. So we have the alternating series test. So first determine if it's an alternating series, and then if it is, then you can use the test. So basically there's two conditions. The first condition is that b sub n is a decreasing sequence. Or not increasing in magnitude. That's the first condition, and then the second condition that needs to be met is the limit as n goes to infinity for b sub n needs to be equal to 0. Okay. And if both those conditions are met, which both need to be met, then we can say that the alternating series is convergent. Okay, so those are going to be the conditions there for convergence. And again, this alternating series test does not tell us anything about divergence. So just keep that in mind. It's very important to remember. Okay, so if we look at what we have, our series here, we can go ahead and determine that a sub n here is negative 1 raised to the n plus 3, and b sub n is going to be 1 over n cubed plus 4n plus 1. Okay. So we just need to go ahead and check the conditions. So let's begin with the first one. So we got the limit as n goes to infinity for 1 over n cubed plus 4n plus 1. I'm going to take the limit there. Well, that's just going to be 1 over infinity, and 1 over a number that is going to get larger is going to get closer to 0. So first condition is met. Now the second condition needs to be met. And recall, again, both conditions need to be met. In other words, it can't pass the first condition but fail the second and be considered convergent, or vice versa. So it does pass the first condition. Now we need to determine if it passes the second condition. So again, we get 1 over infinity. It's going to give us 0. 1 over a number. It's exponentially large. It's going to get closer to 0. Now we just need to check the conditions. So remember, we just have the b sub n and then b sub n plus 1. We stick those in. So we'd have 1 over n cubed plus 4n plus 1 be greater than 1 over, and if we stick in an n plus 1, we'd have n plus 1 cubed plus 4 n plus 1 plus 1. Okay. Now if we plug in values, increasing n will just decrease the denominator. So basically our rational expression will get smaller. So in that case, we can easily tell here that b sub n is in fact decreasing. Now remember for the alternating series, the terms don't have to be decreasing everywhere. So they can be kind of increasing as you go, as you start. They could be kind of increasing. They just need to be eventually decreasing, but they don't have to be decreasing everywhere. That's also a common misconception. They just need to be eventually decreasing. And so we've clearly identified that b sub n is in fact a decreasing sequence. It's not increasing in magnitude. And it also passes the first condition, which was the limit as n goes to infinity needs to be equal to 0, or for b sub n, of course, which it was. And so both conditions are met, which means that this alternating series is convergent. So your final answer here, after we use the alternating series test, we can say that our series from n is equal to 0 to infinity, negative 1 raised to the n plus 3, all over n cubed plus 4n plus 1. We can say that this converges, or it's convergent, so we'll say converges by the alternating series test. And that is your answer. All right, so hopefully that makes sense. So again, I do got other videos on using the alternating series test. So if you would like to see another example, feel free to check that out on YouTube and on Facebook as well as Instagram, where also my math videos and math content is also posted. Okay, so that is going to be it. And I will see y'all next time. Y'all take care.